Hello, everybody. Sorry to be out so soon in the year, but hey, we can have some remote learning just like old times. So hopefully you found some headphones and we're ready to rock. All right, so today's lesson is about slope and perpendicular slope. So if you have a grid here, this is 0, 0 in the middle. Beep. Hold on. This is 0, 0 in the middle. And then we have a 1, a 2, a 3. This is the x values, x coordinates. And so 7 in the x spaces, up and down right here. And then up in the y space, we have 1, 2, 3, 4. Okay, so this line is coordinating different numbers like 2. That's a bad example here. 4, 4. Ooh, 4 4's on there. That's fun. And also 1, 2, 1 comma 2. And there's other numbers in here, like this is 2 and 2, let's see, 2 comma 2 and 2/3. Write that one in there, 2 comma 2 and 2/3. The x value is 2, the y value is 2 and 2/3. All right, excellent. But our question is, as you move up from 1 comma 2 to 2 comma 2 and 2/3 to 3 comma 3 and 1/3, it looks like, and to 4 comma 4 and so on, what is the rate of change? How are those numbers changing? How much per how much? How much does the y change for how much does the x change? Because they're both changing. A great example of rate of change is miles per hour. What are the two things changing there? Your location and the time of day. But how much is your location changing for the time of day? That's your miles per hour. So how much is the y value changing for how much the x value is changing? So we do rise over run. The rise change, which is the y change, over the run change, which is the x change. Okay, hopefully that was all review. Hope you're not too bored. A little bit more review, and then we'll get to the reciprocal stuff. Okay, so you go to a place where the line crosses the grid. Here, it crosses the grid here. And then you start counting up until you notice you can go back. So the next place I can get to the grid is there. So up 1, 2 over 1, 2, 3. That was up 2 over 3. There's the slope, 2/3. Okay. So we can interpret that as 2 changed in the y per 3 changed in the x. It can also be interpreted, if we zoom in, we go up 2/3 of a box. Here's a box. Here's 2/3 of the box. When we go forward 1x. So that's why when you see the equation for these things, you see y equals 2/3 times x, because literally you take the x number and multiply it by 2/3, because you're only getting 2/3 the amount of change per one box change forward. All right, let's zoom back out. Okay, our challenge now is to find the perpendicular slope. From our definition of perpendicular, which is the most opposite you can get from this line, we can determine that if this line is going up as you go forward, then the opposite of that would be going down as you go forward. But it's not just enough to switch up and down. You have to go down precisely in an opposite manner. So if this thing is going up 2 and forward 3, we actually want, for the reciprocal, we want to go down 3 and forward 2. Okay? So notice how this is negative 1.5. So we're going to go down faster than 1, whereas it's going up less fast than 1. The slower you grow in the normal line, the faster you'll grow in the reciprocal line, or the faster you will fall, since it's opposite. Okay, so the key thing to do is flip the slope over. It's called the reciprocal. So put the 3 on top and the 2 on the bottom and make it negative. And then on your worksheet, you need to draw a perpendicular line. So go anywhere on the line and count out your new reciprocal slope. Down 3, 1, 1, 2. down 3, 1, 2, 3, over 2. And go backwards and up. Okay, and I can cheat on this because I have a line tool. There is the reciprocal line. Okay, let's do another example. Okay, so this green line, I gotta find some place where it crosses the grid. Well, it crosses the grid right here. Nope. Right here. And crosses the grid right here. And up 1, 2, 3, 4 over 1. I can get back to the grid. So that was up 4 over 1. This has a slope of 4. But to get the reciprocal slope, we want to, or the perpendicular slope, we want to make it reciprocal. So 4 over 1 becomes 1 over 4 and make it negative. Okay, what? So I just want to pause for a second. Why do we flip it over and make it negative? Well, if this line is going up, up, up to the moon at a rate of 4 per 1, that's like pretty fast. 4 y's per 1x. To be exactly opposite, we need to be going down, but not down very fast, because that would be too much like the other line. Up and down fast is the green line. We want something that is totally opposite that. So instead of going down fast, we're going to go down slowly. We're going to go down 1, forward 1, 2, 3, 4. Down 1, forward 1, 2, 3, 4. And back 1, 2, 3, 4, up 1. Let's make this blue, shall we? There is our perfect perpendicular slope. Okay, just because I can't resist, not only is the new perpendicular slope down 1, forward 4, but if you zoom in, it's also down a quarter, forward 1, 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 haha. So down 1 over 4 is also down a quarter. Yay, slopes, they make sense. Jump cut. I want to talk about one more special case line, and that is the line that goes up 1, forward 1, or a slope of 1, 1 per 1. Yay. So let's write this down. Up 1 in the y direction, forward 1 in the x direction. That's a slope of 1. Okay, but how do we do the opposite reciprocal perpendicular slope? We got to flip it over. But wait, it's just 1 over 1 again, but now it's negative. So when a slope is 1, the perpendicular slope is also 1, but negative 1. So down 1, forward 1, down 1, forward 1. So in the last example, we talked about how if something's going up fast, then to be perpendicular, it needs to go down, but slow. Well, that wasn't a straight line. The exact opposite of up at medium speed is down at medium speed. All right, that's a special case. Nice. Okay, one more minute on how to do the backside of the worksheet. And by the way, you can draw the perpendicular line anywhere you want on the worksheet. On the back side, they give you the x-intercept and the y-intercept. Remember, this is the x-axis, and the up and down is the y-axis. So when it says x-intercept -3, you just go to -3, 1, 2, 3. And when it says y-intercept 4, you go on the y-axis, 1, 2, 3, 4. And then you mark, well, you count out the slope. 1, 2, 3, 4, 1, 2, 3. Then 1, 2, 3, 4, 1, 2, 3. Backward or down 1, 2, 3, 4, backwards 1, 2, 3, and there we go. Then here's our line. Okay, that was up 4 over 3. That's our slope. What about our perpendicular slope? The exactest opposite would be down 3, forward 4, upside down and backwards. So choose anywhere on this line. Here's a good point for me. Down 3, 1, 2, 3, forward 4, 1, 2, 3, 4. And then backwards up 3, backwards 1, 2, 3, 4. And we have our perfect perpendicular. Look at that 90-degree angle. The exactly mostest oppositest line. Nice. All right. Oh, I'm at 10.5 minutes. Sorry this went so long. I'm out of practice on how to make these remote videos. I hope to be better soon, and I hope to see you soon. Everybody have a great day.